A programmable interval timer is the topic of discussion. Uh, Programmable interval timer is a very much similar to it's a kind of a controller which is very much similar, which similarly functions as a software defined counter, as we have already discussed in the previous chapters. And the integrated chip, which is designed by the Intel, which is used for this particular purpose, have been named as 8254. The previous version of 8254 was 8253, and there is a little bit difference in between 8254 and 8253, because 8254 is a little bit more advanced version of 8253. So you can say that 8254 is a programmable interval timer, which functions very much similar to as we have done the programming part, by which we were using the counters as well as the timers. Now the functionality of the 8254 is like that it generates accurate time delay, and that can be used for various applications such as digital count, real time clock, or square wave generator, or any waveform which is complex in nature, waveform generator. You can use there are many applications. Now, as far as the features of 8254 chip is concerned, this includes 3 counters within the 8254, which operate independently at any one of the 6 different modes. So, of course, it is having 3 counters within the 8254, which works in a 6 modes, and it's a 24 pin integrated chip and requires only 5-volt supply. Now, as far as how the counter used to work, there is a 16-bit count which is being loaded into the register, as well as the counter value also is to be loaded. So on the command, it starts decrementing the count value until it reaches to 0. So at the end, when the count has become 0, it generates a pulse, and that can be used to interrupt the microprocessor. And that counter can be count either the binary value, or it can be used BCD value. In addition to that, it can be either in the incrementing mode or in the decrementing mode. The counter can be used. Now, as I told you that. As I told you that 8254 is little bit different, is an upgraded version of 8253. The only difference lies with the 8254 that it can work on the higher clock frequency also. Besides, 8253 works only on the 2 megahertz, but 8254 can operate in between 8 to 10 megahertz. 8254 includes the status read command that can be latched to count the value, the status of the counter. Now, the block diagram of 8254 is concerned. 8254 is a having 3 counters, as you can see on the right hand side: counter 0, counter 1, and counter 2. The database buffer, control read write logic, and as well as the control word register, where the control word is to be written. Now, each counter has 2 different kinds of signal, beside the 3 kinds of signal. One is clock and the gate, which is incoming, and the out is the signal which is going out. Now, the second part is a data bus buffer. The data bus buffer, it is a tri-state buffer, and it is also 8-bit, and it is connected to the data bus of the 8085 microprocessor. Now, the read write logic is concerned, or you can say as a control logic is concerned, we have a read signal which is input, write signal as an input, chip select signal as an input, and A0 and A1 as the address lines. Now, it depends that in what mode this particular is working. Peripheral is working either in the input output mode or in the memory mapped input output. So if it is working in the peripheral mode, input output, then in that case read and write signal will be connected to the input output read or the input output write of the microprocessor. But if this memory mapped input output is being used, then in that case read and write signal of read write logic will be connected to memory read or the memory write Now, as far as the address line A0 and A1 of the microprocessor is concerned, it is connected with the A0 and A1 line of this, and chips. As far as the chip select signal is concerned, it is used. This line is connected to the decoder circuit through which the addresses are being defined. Now, the control word register and the counters are selected. Now, the individual counters which are being used has certain address. So, we have 4 items which has to be addressed. One is counter 0, another is counter 1, another is counter 2, as well as the control word register. So, all these has to be selected depending upon the certain address, and the address which is being used, and it depends upon the value which is being written in the control word register. Now, the value of A0 and A1, the bits of A0 and A1 decides that which is going to be selected. If it is 0 0, the counter 0 will be selected. If it is 0 1, it is counter 1 is selected. If it is 1 0, counter 2 is selected. And if it is 1 1, the control register is being selected. Now, as far as the control word register is concerned, this register, control word register, is being assessed by A0 and A1. If both the values are 1, A0 and A1 are 1, it means the register will be accessed. Now, it is the accessing of the control register is done to write a control word or the command word which specifies that which of the counter has to be used, and the counter which is being used, it is working in which mode, whether it is working in a read mode or it is working in a write mode, in which mode it is working. As far as the format of the control word is concerned, it is given here. It is the control word format. Now, as I have told you that there are many modes in which it used to work. It can work in the 6 different modes, and gate of a counter is used either to enable or disable the counting. So, just to maintain the clarity, the only one mode, that is mode 0, has been shown here, that in mode 0 what happens after the count is written and the gate is high. When the count is written and the gate is high, the count is decremented every clock cycle, and when the count reaches to 0, the output goes high and remains high until a new count or the new mode is uploaded in the control word register. Now, if you look to the status of the control word format, the control word format is defined by the 8 bits. The first bit is D0, D1, D2. D0 represents whether the count which is to be done, it is in the BCD mode or it is in the binary. It is working as a binary counter or BCD counter. And this D1, D2, D3 decides that in which mode it is working. If D1, D2, D3 decides the value of M0, M1 and M2, if it is 0, 0, 0, it will be 0 mode 0, and if the last value is 1, 1, 0, 1, then it means it is working in a sixth mode, that is mode 5. So, depending upon the value of M0, M1 and M2, it is going to decide that in which mode it is working. Now, as far as the bit number D4 and bit number D5 is concerned, it is representing read write value. So, if depending upon the value bits of RW1 and RW0, either counter latch command or it is a read write least significant bit, or 1 0. If it is 1 0, then read write most significant only, or 1 1, then read write least significant byte first. So, and the last one is SC0 and SC1, which represents D7 and D6, and it represents that which counter is selected for the read and write operation. If the value is 0 0, counter 0 will be working. If it is 0 1, it is counter 1 is working. If it is 1 0, it is counter 2 is working, and if it is 1 1, it means it is going to read back the command. So, this is how this is the representation of the format of the control word. Now, as far as the operations of 8254 is concerned, the different mode in which it used to work, as I had told to you that it works in the 6 different modes. 6 different modes, mode 0, mode 1, mode 2, mode 3, like that. So, as far as the mode 0 is concerned, it is a kind of a mode you can also call as an interrupt on the terminal count. Now, in this particular mode, initially the out is low. What is out? Out is the signal which is going outside the counter. There are two input lines, clock 0 and gate 0. So, when it is working in the mode 0, out is always low. So, once a counter value or count is loaded into the register, the count is decremented in every cycle, and when the count reaches to 0, the out goes high till the count value which is loaded in the counter is decrementing, the out is low, but when it reaches to 0, the out goes high. So, this can be used as an interrupt. The out remains high until a new count or the new control word is being loaded. So, if it has to when the new control word is being loaded, new count value is loaded, and then it is going to start decrementing, the out remains low. So, the time when the decrement value, the count value is going to become 0, then only the out signal is going to be high. And why it is used to connect as an interrupt? Because till that particular time there will be certain processes which is going on, and this signal may be allowed to interrupt the processing of the microprocessor and allow the input output devices to transfer the data through the interrupt.